But again, let's start showing you the demonstration of our quality management system, and we'll start new from a 2D drawing. That can be a PDF or a TIFF, of course, and PDFs is like pretty common. And I took a PDF. This is a 2-sheeted PDF, so we have 2 sheets in this particular file. And in this, I'll show you a little bit bigger. So this is the drawing with some dimensions, GD&Ts. We have another sheet in this PDF with some notes on it. The header is quite empty because I got it at some point from a customer, and some 3D representations of this part are also shown. Let's go back to sheet number 1 and move back to the normal size, where you see the drawing in this area and the part properties on the right side, and the bill of characteristics down below. And this is where you will see the content of the database later when we collected the information from the drawing. And let's first start with collecting some information from the header to fill out the part properties that we see on the right side. And of course, this can also be filled by a connection to the ERP system where this information is already stored. So we can create a connection to any ERP system to collect that data or bring in that data automatically. So let's grab this information and call it the part number. This will be read and filled out at the part number level. And we could take this as the part name, for instance. And again, part revision. Well, revision is already but that will show up over here on the part properties. We are able to handle revisions. In a revision change of a drawing, the system will assist you to have as minimum user interaction as possible, to only address to the changes that were made on the drawing. And you only have to address those to have another revision in the database of that particular part. Let's also grab the material. We see the material over here on the header. We can grab that. System will create a material record. And at that material record, I can add extra information like material code or whatever. I'll just type in some nonsense that we will later see in the reporting, like this. I can choose a supplier who supplied me the material and just save it to the database. And of course, I can also add a file like a certificate to this material that my material provider gave me, add it, and now it's also saved to the database. So we are collecting information from the drawing, we're collecting information outside the drawing, and it's stored combined with everything in the centralized database. That's the most important part. Then again, I also want to, while the system will balloon this drawing in a minute, I would like to add tolerances to dimensions that don't have a tolerance on the drawing. Of course, we will collect tolerances when they are with the dimension on the drawing. For not tolerance dimensions, we can set a tolerance table. And of course, for inch drawings, normally the decimal table is used, like the number of decimals will define the number of, the tolerances that will be added. But for metric, and we are working on a metric drawing now, we will normally use a range table like you see over here. And the range table that I by default use is the one that is mostly used by our customers. And that's the DIN ISO 2768. You'll be familiar with that. But for example, I also have other tolerance tables in here also for plastic parts, for instance. I also want to set for the ISO 286-2, so the ISO hole and shaft tolerances. We also want to recognize those, and we'll save these settings. And of course, these settings can already be prepared in a part category, like for a certain part category or for a customer. You can share this as you want. Okay, then we're ready to balloon the drawing. So let's start with automatic ballooning. And I'll, for time saving, I will only balloon the first page of this drawing. And let's start that process. First thing that system does is it'll recognize the frame of the drawing. It'll recognize the header, and it'll search for the mostly used font on this drawing. And with that font, our OCR engine, optical character recognition, will recognize individual characters, symbols, numbers, letters, whatever is on the drawing. And in the last phase, it'll combine all those numbers and characters into dimensions based on what is allowed by the standard. So it has knowledge on how a dimension on a technical drawing can look like. And I'll show you in a second what that means. So then after, let's see, after like it'll report to us. Yeah, there it is. After 45 seconds, it recognized 145 separate dimensions. And I think doing this manual and typing it into an Excel sheet will take you a little bit longer. Let me explain a little bit more in detail how this OCR engine works. So it finds a pixel. It'll find all the connected pixels. And this picture is compared to the pictures of the font that was calibrated. And from that moment on, this is the number 8 for the system. It will search to the left and to the right and to the top and to the bottom for more characters or symbols that could belong to this dimension. And that is identified by this shape. So this rectangular shapes gives us the information how far the system searched for characters that belong to this dimension or that could belong to this dimension. I tell you this because this can be manipulated, as you see, to include more or less information to the dimension. We'll need that later because I'll show you how to work on this drawing for these dimensions, and also include dimensions that are not automatically recognized, because that can happen. And I think that's also important to show you this, because there can be some funny things on a drawing, especially when you are working on a drawing from a customer where you don't have access to the engineer and you can't change anything. You have to solve it with the tools that you have. And I would like to show you some tools that we have to solve those problems. But first, I want to show you a little bit more difficult dimension to recognize for our OCR system like this one. These are actually 5 dimensions. So these are all telling us something about this threaded hole. And in our bill of characteristics down below here, you can see a group of dimensions, 22.1, 2, 3, 4, and 5, that tell us something about this threaded hole. So we have a diameter, a drilling diameter, obviously, with a drilling depth of 8.5. Information about the threaded hole with different parameters, as you see, in this case, thread type, thread size, stuff like that, and a depth of the thread, again, similar to the diameter and the depth dimension we saw before, and then a true position for the whole threaded hole. And of course, that true position can have multiple modifiers, and if they would have been on the drawing, you would have seen them over here, for instance, like maximum material condition or common zone, what we very often see. And of course, the datum fields that they have to relate to. If that would have been on the drawing, it would have been recognized, it would have been shown in the viewer, and we would have seen it in our bill of characteristics. So that's important to know. A little bit more into detail on this dimension is the 2 times, because you see in our multiplier column, we call that a multiplier, that 2 times. That tells us that there is another instance of this threaded hole, and we are already ready for receiving 2 results per dimension. Yeah, that's because of this multiplier. So our database is ready to receive multiple results. We can also split them to make it more clear which result belongs to which instance, because we have 2 instances. And for that purpose, I can use the multiplier button, which is over here, particularly for this dimension. Of course, we also have a multiplier for all dimensions that have a multiplier. So let's use this button. And in my settings, a few things happen. So I'll have 2 separate balloons now, and I can pick them up and drag them to the instance of this threaded hole. And of course, it's not important which hole is 1 and which one is 2. It is important to distinguish between those 2. So now we have 2 groups of 5 dimensions down below in our bill of characteristics. One group 22.1 through 5 underscore 1, and a second group 22.1 through 5 underscore 2. So now each result for each dimension, for each instance of this threaded hole, is stored in its separate line. So now everything is clearly identified, and you have a full traceability on who did measured what on what instance of what threaded hole. So this is a little bit more detail to show you what we are capable of. Okay, let's go back to the ballooning part, where I told you that it is important to check if all dimensions were ballooned, and to show our tools how to handle that if there are some dimensions that could not be ballooned automatically. And I think it's important to show you this, and the tool that we created to quickly identify those dimensions that were not ballooned automatically is our whiteout balloons tool. So using that tool, you see that the balloons are still there, but they are hidden. They're white out. So now you can clearly recognize 3 dimensions here that were not automatically ballooned. And let me show you the reason why, and also how to balloon them. Reason why this dimension was not ballooned is because it's in a different font. And that's perhaps because the area is very small over here, or perhaps it's in another revision. I don't know. I do need a tool to collect that dimension, and that's this balloon dimension tool. So let's create my own rectangle around this dimension, forcing the system to recognize a dimension. And now it'll look with a broader scope to identify this dimension. And then you can see that it recognized this dimension and also added the tolerances from the general tolerance table. Over here we have another dimension, which is a basic dimension. Well, that dimension you would normally not balloon, but I promise to balloon everything. Reason that this is not ballooned automatically, I think you can guess, because I told you before that all pixels that are connected will be recognized by the system and then compared to the known pictures of that font. Well, over here everything is connected. That arrow is connected to the 8. The rectangle is connected to these dimension lines. It's a little bit of mess of everything, and that makes it impossible for the system to recognize. So that's why it says unknown, and that's not bad. Let me assist the system a bit in recognizing this. So it's a linear dimension, and the tolerance type is basic. It has a rectangle around it, and in the viewer, you'll see the dimension appear while I'm using the parameters to define it. The nominal value is 8, and the tolerances I would like to have updated automatically from my settings or my tolerance table, and in this case from my settings. And in my settings, all basic dimensions who actually don't have a tolerance will get a tolerance of 999. With that said, I can save it. this is the first time that the second time that you see me use the save button, because the system will save everything that you do automatically. It will record and save everything automatically, and that's also important. Last dimension that was not recognized is this one, and I'll show you why. If I draw my rectangle around it to have it recognized, to force it to look at it, you can see that it recognizes the depth symbol and the 0, but not the 9, because this line is connected to that 9. Same for that minus symbol. This line is connected to that minus symbol, so that's also not automatically recognized. So it was partially recognized. And let me also assist here a bit. So depth symbol is okay, it's a depth dimension, but it has a tolerance on the drawing, so let's use that tolerance. The nominal value is 0.90, and the upper tolerance is 0, and the lower tolerance is minus 0.1. I have to reach out a little bit for my keyboard because it's underneath my screen, so that looks a bit funny. And we'll delete this node and save it like this. And now we have a completely ballooned drawing. And I think you will have the same experience on drawings that you get from your customers. So it's important to have tools that intelligent tools that will assist you in creating that 100% correctly ballooned drawing from your customer. The usual question that I have when we do a personal demo, we'll save your questions for answering at the end. But the usual question that I get at this moment is, well, you balloon those 3 dimensions by hand now, but they are at the end. They are not in line with the numbering of the rest of the dimensions. So they are right at the back of the bill of characteristics, as you can see here down below. Well, we can always renumber all dimensions, and then the system will renumber from top to bottom and from left to right. So the drawing will be scanned like this, and the numbers will be renumbered in that order. You can also restructure the numbers by view, that's possible, or even change one individual balloon number. It sometimes happens that you'll get a drawing from your customer and they already ballooned a few dimensions, perhaps only the critical dimensions. And those critical dimensions then have their own number. And the purpose of your customer is often that you report back on those dimensions using those balloon numbers. That's possible. You can individually change the balloon numbers on a drawing if you want to. And of course, it'll stay unique. So there will always be unique numbers. Some cosmetic things like colors, shapes of the balloon, the position of the balloon, you can create in the drawing preferences, and you can set them to your own preferences. Whenever a balloon lands like here on the side of the drawing, you can just pick it up and bring it next to the dimension. And if you drag it too far away, a leader will appear, and the shape and form of that leader you can also define in those preferences that I explained. Okay, that's all I wanted to show you on ballooning. And as said, we can also do this from a 3D CAD file with PMI. It's not an industry standard yet, but then I would have started not from a drawing, but I would have started from CAD file. And that meaning that we would need a native CAD file, 3D CAD file, with the PMI already in it. And the major CAD systems can do that. But as Andrea said, there is no 100% standard yet defining each and every dimension type and GD&T type and characteristic and stuff. So there are some variations still. So there are some problems adapting to it. We are ready for it. We can recognize it, and we can also recognize the step 242, the standard step file for a 3D CAD file with PMI. We can read that as well. Okay, when we have ballooned and we have created the bill of characteristics, we can prepare this information more for the quality process. And I'll just give you a few examples of what we can do and what you can use. And as said by Andreas, we have a gauge management system in our system, and that's because we want to keep all the information connected. So each dimension that is measured will also have the information of the tool it was measured with, and also the information from the person who measured it. In this case, I have all my tools listed in my measurement gauges, and all the information that you can store in a database is gauge information, so general information, like a gauge ID and a title and a gauge category, a serial number, of course, to make it unique, and location information, where it's stored, but also current place and current user. So you never have to search for a gauge because you can use it as a check-in, check-out system. Also maintenance information, and of course very important calibration information, like who calibrated it, when was it last calibrated, what was the calibration data, and what was the result, of course, how often should it be calibrated, etc., etc. All important information to make sure that this tool was calibrated at the time that it was used. And if it's connected to our system via Bluetooth or cable or whatever, then we will collect that information, but we will never collect information or accept information, result information, from a tool that is not calibrated. So that's out of calibration. And that's also very important. From our customers, we also hear that it's very important to be able to show this whenever you get audited by your customer or by an organization that can certify you. Andreas was talking about the ISO standards, and for that, of course, you have to be audited. And if you show the system that you are using for your quality management and your gauge management, we hear from our customers that a auditing doesn't take you days anymore, but instead of days, you'll be done in hours. Because we store all information for each dimension, also with the gauge, we can build up a usage history. So you will know where this tool was used to collect data. Okay, let's go back to my part, because I have to speed up a little bit to make sure that we don't get any further delays. I'm sorry for that, but again, we can do a personal demo for you if you think it's interesting enough, using your own drawings, and I'll make sure that my Bluetooth of my laptop is fixed by then. So let's go through something more on work preparation. We saw gauge categories. We can use designators like a critical dimension. So if we go to a dimension, and we can set a designator for each dimension, like a critical dimension or key or major or minor or whatever. And you can also create your own designators or your customer's designators, grouping those dimensions together, perhaps with the purpose to report on them, or to make sure that they are measured more often than the normal dimensions that don't need special attention. Something else to mention is the sampling rule, and in this demo I will use the AQL table, acceptance quality limit table, which will define how many samples I have to take for a number of parts that I have to produce for a purchase order. Something to mention is manufacturing operation. Let me quickly go to that before I'll go to creating a job and data collection. So manufacturing operation is we can define for each step of the manufacturing of this part, we can define the dimensions that are like created in that step. So let me use the simple example of the first step of cutting a block of raw material for milling this part from. So let's create a new operation using the outer dimensions, and these are not really the outer dimensions, but let me just select 3, like length, width, and thickness, and create a new operation. And that operation, I can also change the parameters. So let me just call it raw material cutting, so we can recognize it. Raw material cutting. Okay, save it like that. And now I have the finished part. That's by default. That's what we create in our system, because those are all the dimensions of the end, the finished part. Now we also have a raw material cutting drawing and the dimensions that belong to this manufacturing operation. Of course, these are the end dimensions, so the finished dimensions. So let me show you that we can also change those dimensions using the bulk update function. And I would like to add 4 millimeters to the nominal value, and I would like to set the tolerance to plus and minus 1 millimeter, like this, applying close. So that'll give you an example that you can define the stage and the dimensions for each separate step of the manufacturing process, giving you control over that process and also results data on that process. So you can prevent errors from happening before you move to the next stage, because you checked the dimensions and you didn't do that on paper, you did that in the system. So it is immediately recorded and corrected that this process is not correct. You can change the process, reset the machine, or use your other tool to create a correct process and carry on. So that'll prevent you from creating faulty parts. And that is what we hear from our customers, which saves most of the time and therefore also most of the money, of course, because if you produce a faulty part, you actually use your machine 3 times for producing the wrong part, producing the new part, and in that time you could have produced another part. So it's 3 times over using the machine and the people running the machine. Okay, let's quickly go back to the finished part and go back to our original drawing. Okay, some minutes left to do data collection. Of course, we can create a new balloon drawing, and that shows up in my other screen, so I'll drag it in here. I can create a balloon drawing from this drawing with bookmarks that'll lead me to the right dimension. And you can use this PDF with bookmarks as your digital drawing. You don't have to use it on paper, and it's automatically stored in my files section of this part. So I have the source drawing and a balloon drawing as well. I can also create an inspection plan from this part, and that inspection plan is like an inspection report, but without results, because we didn't collect results yet. And I'm using a template to extract information from the database and put it into a certain format, in this case in an Excel file. And you can use that to give it with your balloon drawing and this inspection plan to your supplier or your shop floor people, because for us it makes no difference if it's for your shop floor people or for your supplier, and ask them to fill out the Excel file with the results and read that Excel file back into the database to store all the results to the right dimensions of the right sample of this job. And that's, of course, important to be able to have full traceability on these samples. Okay, so this is what it looks like. It's an example. It can look like anything you want. It can also look like your customers' inspection reports or plans. You'll have access to our tool to create those templates to create your own plans and reports. I will use this one to also show you how to import those results back in our system. Okay, let's put it over here like this. Normally you would never do this, of course, but I will save this so I have a file to show you how to import. Let's see, put it on my desktop and I'll call it Neely so I can recognize it like this. Save it. Okay. Okay. And let's quickly go for data collection for a few more minutes. Next thing I'm going to show you is that we will create a job in the database, and this can also come from your ERP system with all the job, lot, and sample information. And let's tell the system I have to produce 20 of these parts, make them active to be able to create, to collect results, because when it's still in planning, I cannot collect results from it. Shop floor people can't see it. And I will then be able to also create lots for this PO. In this case, I will only have one lot. All 20 parts will be produced in one go. But if you have large POs with large numbers, large quantities, you can separate them in different lots. Let's make that one active. And let's create samples based on the AQL rules that I have set in my system in that lot one. So now the system will define 3 samples, as you can see over here, according to these AQL settings that I use for my demonstration, but you can also combine it with manual override, of course, and also on the the sampling rules for each dimension to create different dimensions for different samples. In this case, I will get 3 samples with 3 different serial numbers and also with different numbers of dimensions to be checked, because most of the dimensions have a sampling rule of AQL based, but some of them have a sampling rule of 10%. Perhaps you saw in my bill of characteristics before, so that's why we have different numbers of dimensions. Okay, let's quickly show you a little bit about data collection. So now I have the samples available over here. Move to sample 1. What I'm going to do now is what you normally won't see, because that will be collected automatically. But I'm looking actively at sample number 1 now, and I will import results and import it from a file. And we can do that from any CMM, VMM, whatever machine is producing a result file. And therefore we use a preset. A preset is a system that can recognize the format of that file. And we have presets for every CMM, VMM. And if we don't have it yet, we can create it for you. It's included in the basic functionality of our system. So that preset will read that result file that I created before. That's why I'm using the inspection planner preset. And I'll tell it that I measured it on sample number 1. And then the results will be connected to the dimensions for this sample, so for this serial number 1, for this job, based on the blue number. So if you program your CMM, VMM, you only have to take care of the blue number, the rest we will take care of. This can also be done automatically. So green on this color-coded drawing for sample number 1 means it's measured and it's within tolerance. red, it's measured and it's out of tolerance, and this is a minus tolerance. So I copied I copied the nominal to the actual. So with a minus tolerance, this is red, it's out of tolerance, and gray meaning it's not measured yet. For instance, this threaded hole cannot be measured by a CMM, of course. So I can also add a result over here in my results editor. It is passed, I can store it, and now it's a little bit more green. Last but not least, I'll quickly show you on another sample, because I really have to speed up. I will show you how to collect results from the shop floor data collection system. And normally, let's see, that's this application. This is a browser application, and I will log in again because I was timed out. Mine is running on a server in the US somewhere. So I'll have to log in again. If your part has a QR code or barcode, you can just scan it using a camera. This is an application running as a browser application on your server, and it is developed for a touchscreen tablet, but you can also use it on a normal computer or laptop or whatever device that can browse on your server, on your network. So you can find the part using these parameters, or you can search through this gallery of drawings. I'll use this drawing. There's my job 226 that I created with the 3 samples. I'll go into this job, sample number 1, where we already have a lot of results imported. Sample number 2 with serial number 7, nothing measured yet. So let's dive into this one. So this is what the shop floor people look at for data collection. And they'll see on the left side the dimensions they have to measure. This can also be a short list if it's only a few dimensions for those manufacturing steps. The drawing that you see over here, same drawing as we see in the main application, like this. And there we can enter results. So we see the dimensions parameters over here, and here we can enter results. I can use this touch screen. I don't have a touch screen on my screen, so I'll use my mouse instead. 14818, for instance, accept. And okay, it'll jump to the next dimension. Normally, I would use my Bluetooth caliper. I have a Silvac Bluetooth caliper for my demonstrations. I turned it on, but it's also not connecting to my Bluetooth. So I think there's a Bluetooth problem with my Windows. I'll make sure to fix it for a next demonstration. But when we go back to the main application, we'll be able to see when I refresh the screen here. Let me here, F5. It'll refresh the screen, and it shows us also the results that were collected using that shop floor data collection app. That shop floor data collection app can, of course, also be used in the quality department or incoming goods section. And when I go back to, for instance, sample number 1, because I have more results over here, it looks better. I can create a single piece report. And now I'll use another template, the AS9102 template. For those who are working for aerospace, they'll be familiar with this format. And this is a format according to that standard. The template will extract the data needed for to fill out this form to create that inspection report. And this is the report that is then created. But form number 1 with part information, form number 2 with material information, with the nonsense that I typed in the beginning, form 3 with all my results that were imported for this serial number, and perhaps attachments, in this case a material certificate and a ballooned drawing. So this is what I wanted to show you on the product demonstration. We can go to the Q&A now, Lisa.
Great. Thank you so much, Hans. And thank you everyone for spending the hour with us.